Okay,
We
sir.
know that when I am outside this city, IIT, network problem is there. Because Thursday and Friday, I will be in Bangalore for some other important project discussion. I have to be there 2 days. And I can get connected because we know that the bandwidth, all this problem. IIT has very good bandwidth. Here also we are facing problem. Similarly, next week also, most likely Monday and Tuesday may not be there. Again, or Tuesday or Wednesday, something like that, out of IIT Madras. But teaching I can do online only, but the main problem is you understand many times get connections. So what I will do is majority of classes, if there's a class, I will intimate you one day before. Otherwise, whatever my lecture, I will record and send it to you. I may record most of the lectures by this weekend and another 8 lectures or 9 lectures, record and send it to you. And you can go through the lecture video. And if you have any doubts, we can online next week also, one day we can discuss. This is how I'm going to complete the portion for this code. Another 8
Okay,
to
sir.
9.
No issues.
Today I will take class.
No.
After most of the things will be as a lecture, 8 to 9 lecture. Recorded lecture will be put on my Google Drive and I will give you a link. You can download and do. Okay.
Sure,
Okay,
sir.
if you need some classes, we can do that. Otherwise, it will be all recorded only. Because since these 2 weeks, I have to travel extensively, 2 to 3 days. And network issue, because I cannot teach online. That's why. If IIT, I am very happy to teach. Correct. By generally, I don't do recording and sending. But this time I am forced to do some at least 4 to 5 hours. So I decided to record most of the lecture, what I have to do. And also the previous lecture, also important lectures, I will record and put it on this one. Okay.
Sure, sir. Sure. Thank you for the update, sir. Sir, just one question, so the Google Drive will be able to upload, right? Like it will have enough space, right? We will not have any problem.
I will, because I am going to put in my drive, no? IIT,
Okay.
I have Smail account.
Sure, sir.
Correct. It is a Google Drive has sufficient space. I will put it. Okay. So that you can download.
Sir, assignment sheet, can you give
that also I told you Friday I will send. Assignment sheet I will send by Friday.
Because next Wednesday is our last class. That is why I'm asking.
No, I will send this one. The lectures, apart from today, another 8 or 9 lectures will be as a recorded form. Okay, so you can go through, that will be a portion, which will cover entire portion of what we shown in the syllabus. Okay.
Sir, and one more request is, if it is possible to include, maybe in one of your lecture, or like what type of just proportion that you will be asking the questions in the exam, like in a sense whether it will be like more. I think you have already mentioned that. I think we also discussed yesterday that about the percentage that you'll be asking after the midsum portion that you have taken, and
that will be around 60%, 40% will be from the before midsum. Up to midsum, 40% in sum, 60% will be after the midsum.
Okay, sir. Okay. And about the problems, or it will be like more?
No, it will be like you saw last semester, no? Similar to that. Exactly. See, last time mechatronics you saw, no? There'll be a problem, there'll be a theory, define, simple. Your question will be 10 marks. It will be divided into 3-4 parts. 2 marks, 4 marks, 5 marks. Correct? Like this. Exactly similar to what the mechatronics we did. Same way. You saw midsum example also, no?
Yes, sir. Yes.
Same way. 6 questions will be there. Each will be 10 marks. Each will have subdivisions.
Sure.
3-hour exam.
Sure, sir. Sure.
And you are going to come and write in the exam only, in IIT Madras only.
Sure. Sure, sir. Thank you.
Okay.
Sir, we can start, sir. Now, I think people are there.
How many are there? Only 14.
So here,
no,
sir,
because
conference hall we are sitting, sir.
Yeah, I know that, but still I see only you have 6 or 8. 10 or
10, sir.
You are 10 or that, and that will be 24. Okay, around, slowly they are joining. We will start. Fine. Okay. Now, first thing is I have to share the screen. Screen is visible?
Yes, sir. Yes.
Screen is visible. I will make it full screen. He fine. I think you are able to see the screen. Okay, we were discussing about batteries yesterday. Basics of battery, what is a battery is made of. And type of energy storing started with basic voltaic cell. We talked how it works. The voltaic cell, which is made of copper and zinc electrodes with diluted H2 as electrolyte, and it produces 1.1 volt because the material used is copper, and this combination, one is called as a positive material, other one is called negative material. Already told yesterday, if you use the combination, then it produces only 1.1 volt. Again, I told you the voltage produced by galvanic cell, irrespective of size. I'm talking of volume of the electrolyte as surface area. This one will be always 1.12. Only the current will increase. Bigger the battery, it can deliver more current for longer time. And power equal to voltage multiplied by current. The voltage is going to be 1.12 volts. If current is 1 amps, you say that it will 1.1 watt, correct? Multiplied by 1. If it is 1,000 amps, then you will say 1,001 watt, correct? Like that, the voltage, the power increases based on how much current is produced by the battery. That depends upon the size of the battery. That means volume of the electrolytes available and the surface area of the electrodes. Bigger the surface area, more electrolyte will touch. So it creates more electrons, more current, more electrical power. That already told, we are not going to repeat that. So then we talked about what it consists of. Yeah, and positive electrode, negative electrode, and which is called anode and cathode, and is an electrolyte due to redox process, which is called reduction oxidation process. The electrochemical cell, all batteries are electrochemical cell. They produce the electrons and ions. They flow. The electron will flow to the external circuit. That is our load, and because of that, the power is consumed, energy is produced. Maybe a light or a force or a torque, the actuator generated. That already we saw. Then I told you there are, any battery should consist of two types of material. One is called anode material, other one is called cathode material. There is a set of anode cathode material in your periodic table, and you need to use one anode material plus another cathode material, some combination. The best combination, what is the best combination? Best combination provides maximum voltage. Best combination should generate more EMF, generate more EMF or higher EMF. In that regard, we will see that lithium-ion battery produces 4 volts. Individual cell can produce 4 volts. The smallest one is voltaic cell, which is 1.1 volt. If you say nickel cadmium battery, individual cell 1.2 volts or 1.3 volts. If you go to dry cell, which is a batteries, all those things, cylindrical shape, they produce. They are zinc and zinc oxide as electrodes and zinc sulfate as electrolyte. We call it dry cell, and it produces only 1.5 volts. The voltage per cell, correct? And if you go to lithium-ion battery, individual cell produces 4 volts. It is twice that of lead acid, correct? 3 times of the dry cell, 4 times of close to 4 times of voltaic cell. That's why nowadays we are using lithium-ion battery. That means if I want under, say 400 volts, I connect. I told you that when I want to have more voltage, individual cell produces 1.1 volt, 1.2 volts, 1.5 or 2 volts or 4 volts. If I want more voltage, I have to connect the individual cells in series. Then when I connect cells in series, it is called as a battery. Battery means a group of cells put in single container. They are connected in series fashion. They produce more volts. Number of cells, the voltage of the battery. Voltage of battery is equal to number of cells, N multiplied by individual cell voltage. I can say that V cell voltage. So depending upon, for example, 6 cells are there. If it is a lead acid battery, it will be 12 volts will be produced. Instead of that, 6 cells, I have lithium-ion battery. 6 cells are connected in series. Individual cell 4 volts. You can see that it will produce 24 volts, double the voltage. Correct? So this is how. Now If I want more voltage, I will connect batteries in series. As I told you, this is cell in series. C1 connected in series with C2, connected in series with C3. Okay. So finally, I call this a negative electrode of the battery. This is called a positive electrode of the battery. Okay. So the whole thing is inside one box. But each one is separate compartment. If you see lead acid battery, there'll be a 6-volt battery. If I take 6-volt car motorcycle battery, there'll be 6 compartments. A big box, something like this, rectangular, which will be divided into 3 compartments, totally separated. Okay, and within that there will be 2 electrodes, positive and negative. So then they are connected. So you have a positive electrode and you have a negative electrode. Let me use another color, you will understand. So this is positive electrode. Again, there's one positive electrode. There's another positive electrode. Similarly, you have negative electrode. Again, one negative electrode. Again, negative electrode. So now each cell, this is C1, C2, C3. Please see that they're separated, physically separated. This is filled with electrolytes. Electrolyte is filled with each compartment. Okay, and they cannot mix because they are separated, physically separated. Inside that, you have 2 electrodes. So the C1, C2, C3 are there. This produces 2 volts. This produces 2 volts. This produces 6 volts. I want 6 volts. What did the battery manufacturer? Take the negative electrode of the first cell, connect it to positive electrode. Let me use another color so you can see it. So this is connected like this. Again, this is connected, short circuited. Finally, a bigger terminal is there. This is called negative terminal, and this is called as positive terminal. This is what you are seeing outside, correct? The 6-volt battery. If it is a 12-volt battery, you have bigger container. You have 6 compartments. Each will be 2 volts, 2 volts. 12 volts will come. If I want 24 volts, correct, I will have 12 cells, 12 compartment, big, correct? 48, like that it happens. This is how the battery works. You understand? Okay. So now our interest is to talk about lead acid battery. Already we talked what lead acid battery consists. Correct. So lead acid battery. Let us talk about lead acid battery. Okay. Lead acid battery. This is the pictorial representation. It has a container. It is filled with electrolyte. My electrolyte of lead acid battery is diluted H2SO4. That means H2O plus H2SO4. In proportion, I told you, this can be 10 to 15% water and plus and 90 to 85%. Sorry, water is extremely sorry. This is going to be okay, 85 to 90%. Exact number you can see in the manual. Okay, and this will be 15 to 10%. 10% water will be less. Okay, I made a small mistake. Oh, sorry, water is more. Very sorry. Okay, what I written is, let me write once again clearly. This will be 85% to 90% water, and this will be 15% to 10% is the H2SO4, sulfuric acid. Okay, so that is acts as a this one. Then we have the positive terminal. Okay, this is made of PbO2, lead dioxide. So this is called as positive terminal or anode. Similarly, I have cathode. Again, that is also immersed inside the electrolyte, and this is called as negative terminal, also called as cathode. Okay. Now, this is H2SO4 is there. Water is only for dilute concentration. So main constitution, the electricity is produced by this H2 by breaking the H2SO4 into separate atoms and finally stripping the electrons from these two. Okay, hydrogen and sulfide. SO4 is called sulfide. But these are first separated because basically this is a single molecule. Okay, containing the hydrogen 2 atoms, one sulfur atom and 4 oxygen atom. They are all bonded together, single molecule, chemical bonding. That's why we call sulfuric acid. Okay, it is in liquid form. Now, once I immerse my cathode and anode inside the diluted sulfuric acid, what happens is at the anode, 2 H plus is called as a positive ion because it is nothing but hydrogen ion. Positive ion, also called as hydrogen ion, H hydrogen. I told you in previous class, maybe if you take a hydrogen atom, it has a nucleus. This is the period, the basic element in the periodic table. It has one proton, which is a positive charge, and around that there's an electron is circling around. Electron. So electron is negatively charged. This is rotating or orbiting around this. So this is called as hydrogen atom. Hydrogen atom has one positive, one electron. Both are equal amount of charge wise. Mass wise, they are different. You know that electron mass is very, very small. Correct? I think it is 10 power minus 24 kg, 1 into something like that. Okay, so small. But the proton is 1800 times higher mass compared to electron. 1800 times or 1600, exact number you can see in the book. But the charge wise, the electron has 1.6 into 10 power minus 19 coulomb. Coulomb or charge. Coulomb is the unit. 1.6 into 10 power minus 19 is so small. This one. So same amount of positive charge is there at the proton. That is nucleus. Same 1.6 into 10 power minus 19. But it is a positive charge. This is a positive charge. This is a negative charge. So when both are there, the hydrogen atom become neutral. Hydrogen atom is a neutral. That means it is not positive. Now, this hydrogen atom is combined with SO2, all those things I told you. Once, which is sulfuric acid, once I insert this, automatically what happens is the hydrogen atom molecule is separated. Molecule 2 atom, this is separated, and this separated one from this, the electrons are stripped. Electrons of the hydrogen atoms are stripped. Then they become ion, hydrogen ion. Only protons are there. Okay, so they come and get deposited. These ions will come and get deposited. First thing is, on the surface of the anode, the sulfuric acid is divided into H2 and SO4, and the electrons of the hydrogen atoms are stripped, and hydrogen ions will be the positive. They will be retained at the anode. The electrons produced here will move towards, this is electrons. Stripped electron of hydrogen atom moves towards the cathode. They get deposited here. Okay. So the hydrogen ions will stay. Because of that, this ion become positively charged. So we say positive electrode or anode. So since the electrons created during the electrochemical process, which is called as a redox process, reduction and oxidation process. I told you yesterday, chemistry, reduction process means removal of electrons from the atom. are stripping down the electrons from the atom, but it requires external energy. That's what happens. Chemical action happens in the battery. We saw that. So that is called as reduction process. Other one is called oxidation process. Oxidation is if electrons are attracted and admitted or added to a atom or a ion, it is called as oxidation process. Both happens inside this one. First thing is in one plate, in this one, this happens. Reduction, first process reduction. Reduction process creates electrons. Reduction process creates electrons inside the battery, and where on the surface of the anode, and from the hydrogen atoms, and they will be attracted, get deposited on the cathode terminal. Okay. Similarly, the SO4, once it is SO4, the hydrogen become H plus, positive ions, by stripping this one. Similarly, SO4 also will be stripped of a positive charge, then it becomes SO minus. So this will become SO4 minus. That means there are 2 electrons are there. Correct? This is SO4 is sulfide, which has 2 electrons, so it is negatively charged. And hydrogen was removed by electron, it becomes positive charge. So the positive charge will come and get deposited in the anode. So this will become positive charge. The electrons stripped from the hydrogen, also from the SO4, will get deposited here. It becomes negatively charged. This is how the electrode. So this, once the H2SO4 is broken into individual atoms, stripped of electrons and this one, and get deposited electrons on this one, the chemical process ends. Okay, one molecule is so that like this, one H2SO4 produces 2 positive ions and 2 electrons. Correct? So from this, so now the electrons will come and deposit. They're waiting. Since the charges are stored on the 2 electrodes due to the chemical process, which is called redox process, right? So it generates 2 volts. Lead acid, that is due to why one electrode is PbO, other one is Pb. Correct? So one is a positive material, other one is a negative material. So if I use this combination, that cell, electrochemical cell, will generate 2 volts. Why we are calling as a lead acid cell? We are using lead and lead oxide as electrodes, and we are using sulfuric acid as an electrolyte. So lead materials plus sulfuric acid forms lead acid battery. Correct? Yesterday we saw. Similarly, if I talk about copper as a positive electrode, zinc as a negative electrode, they are positive and negative electrode immersed in the same H2SO4. It becomes a galvanic cell or voltaic cell. Okay, because it was invented by this person. Together they help to form this one. So it called as how much voltage produces? 1.1 volt. Because that combination, copper is a positive and zinc as this one, electrolyte H2O4, it will generate only 1.1 volt. So generally what we want more power. Power in electrical V into high. Higher the voltage, higher the current produced by battery, more power is produced by particular battery. Okay. For example, I have one lead acid battery container, which is a volume of say 100 ml, correct? And it has positive negative electrode filled with 100 ml of H2SO4 electrolyte. It produces, and it has PbO2 and Pb. So it will produce 2 volts, and that is called EMF. How much current it will produce depends upon this volume. For example, this battery produces 1 amps. Correct? It can supply 1 amps current for 1 hour. We call it ampere rate. Then we know that the power delivered by this battery is P equal to 2 into 1. This is V, this is I. That means it generates 2 watts of power. This battery generate 2 hours. If I want more battery, more current or more power, what I do? I make a bigger this one. So 1000 ml container filled with 1000 ml electrolyte, and again same PB and PBO lead acid, that is electrolyte, this one. This will produce again 2 volts, but current can be 10 times, correct? That means 10 amps. What is the power? 2 into 10, it is going to 20 watts of power will be produced by this battery, bigger battery. Please see the voltage is same, current here. Net power is, I said, if I want more power to be or more current needed, I have to make bigger battery with more electrolytes and bigger electrodes having bigger electric surface, because the electrons, all those are created not on the middle of the battery, it is on the surface of the electrodes. So more electrode area, more current produced, correct? More power is generated. Okay, this is how it works. Right? We know how it works. Okay, now this is how it works. Now we will see the chemical reaction, what happens in the, again. So this process is called as discharge process, correct? The process, there are two processes in lead acid battery or any battery. Lead acid battery. There are two processes. One is called discharging process. Other one is called charging process. What we saw is discharging, correct? So the battery produces EMF plus current, which is allowed to flow through the load. As I told, for understanding again, I will redraw. This is my lead acid battery. This is a positive terminal. This is negative terminal. I connect my load R. So this is plus, this is minus. I say current is flowing from, this is called anode, this is called cathode. Current is flowing from, this is filled with electrolytes, right? So current is flowing, this is I, and there's a voltage V. This is 2 volts, and the current depends upon how much the electrons are produced in these electrodes, correct? That depends also. So the current is flowing, and also depend on resistance value, R equal to 10 volts. The resistance control how much current can flow between anode to cathode, but the current produced depends upon the surface area of the battery, this one, and volume of the electrolyte touching the surface at given instant. Okay, this is how it works. So this process is called as discharge process. Why? The electrical energy is produced on the terminals as electrons that is circulating, and power is produced. Power equal to as a heat, because the resistance, the power is consumed as a heat. V into I, this much power, so many watts of power will be consumed by this load. Electrical, it can be bulb or heater or a motor, whatever. So power is produced by this much power is produced by this battery, it will be consumed by this. So this process is called discharging. Why it is called discharging? I told you H2SO4 is broken into two pieces, H plus, and also this will become SO4 minus minus. Okay, so these electrons will be circulating. The electrons are moving through the load. That is what we call a current flow. Okay, the current, these electrons coming out this one through load, where it goes, it reaches anode. There you H plus. So the H plus is waiting for this electrode. Again, yesterday I told you the electrons from the surface of cathode cannot move in the electrolyte from cathode to anode, not allowed. This direction is not possible. It can go only through external load and come. Once it come here, the H plus ions, correct? The H plus ions which are waiting here is eagerly waiting for these electrons to come through the load. Correct? It produces. It once comes, they both combine, they become the neutral. Now hydrogen atom is produced. Correct? Hydrogen atom is produced. Previously the H plus plus one electron coming from the cathode of the battery through the load. Now the result is nothing but hydrogen atom. Okay. This atom will join with the oxygen atoms available in SO for sulfide, and will become H2O. Okay, what happened? I had Previously, I had H2SO4, for example, 10% volume, and H2O water was 90%. For example, it is diluted. Now, as I start consuming power during discharge process, what happened? This was broken and it divided into H plus ions on this one. And once it comes, the electron comes through load to the positive electrode, the H plus was waiting. It joined, it became H. And H will combine with the 2H will combine with O, will produce H2O. Correct? So what is this? Water. So this was converted into water, and SO4 is called sulfide. It is called a sulfide that will be deposited as a particles. So you can see, if you open your lead acid battery, bottom of the surface, you will see black color material, individual spongy black. What is that? That is nothing but your sulfide. Correct? The sulfide will be this one. That means your energy is produced from the sulfuric acid. By breaking sulfuric acid, create the electron, this one, and finally it converted to water. This is converted into water plus SO4. So this will be deposited in the battery as a black color particles. Correct? They become non-reactive material. Sulfide, final, this is non-reactive. Correct? And water is added. So that means initially I have 90% water, 10% this one, and this will start ready. As I consume power, minute after minute, this will become 9%, this will become 91, this will become 8%, this will become 90%, like that. After 1 hour you consume, what will happen? Almost most of the H2SO4 will be converted to water and sulfide. So the sulfuric acid, H2SO4 percentage become 1%. This will become 99%. If it happens, the voltage produced by individual cell, which are 2 volts, will start reducing. Correct? It will try to remain constant for some time. Once the amount of the H2SO become lesser, the current produced become lesser, the voltage will start dropping. Correct? Almost after some time, the voltage may become 1 volt or 0.8 volts. We'll say the battery, it can become 0 also. If we continue to consume, it will become bad. We say the battery completely discharged. Correct? Why? There is no more H2SO4 to produce the electrons required for producing electricity, which will flow through the battery. Correct? So this is called a discharge process. Now, one thing is, when we talk about battery, I forgot to tell yesterday, there are 2 types of battery. Battery can be classified as, one is called non-rechargeable battery, or primary battery. These are the words they use, primary battery. Okay. Other one is called rechargeable battery. Non-rechargeable means only one type. If you take, for example, I told you our dry cell. Dry cell generally look like a cylindrical, and the top you will have metal cap. Correct? This will be marked a plus. Bottom side of the battery will be negative. Across this, if I connect a bulb, for example, a torchlight, if you connect, so this produces 1.5 volt. In the center, what you have is a carbon electrode. If you open your dry cell, please, it's chemically toxic, don't touch. But if you have a gloves, all those things can break open. You will see the center is a carbon rod. Correct? Solid carbon rod. That is called a positive electrode. This is the positive electrode in dry cell. And the body is made of zinc. Zinc is negative material. This is cathode. The body of your dry cell, whether AA, AAA, AA, all this thing will be in cylindrical shape. Industry standard, size, diameter, everything is height, everything is fixed. Okay, AA means this one, AAA means this. Standard is any company, everybody can produce, Nippon can produce, anybody produces. AA means the fixed, this length will be fixed, this diameter is fixed. The inside that you have carbon, solid carbon as a positive electrode. The body is made of zinc material, that is the negative, this one, and the inside which it will be filled with paste. dry paste. That's why you call dry cells. It is not liquid like a lead acid battery. You have diluted sulfuric acid, 80%, 90% water with 10 or 15% is the sulfuric acid. This one. In the case of it is paste. It is a zinc sulfide. Correct? Z10SO4 sulfide in the paste form. In the paste form, it is filled with this. So that's why called dry cell. No liquid, so dry cell. This produces 1.5 volts. Okay. This cell is called as a primary cell, primary battery or primary cell. Now, again, the zinc sulfide will be broken into zinc plus and also electrons, and sulfide will be broken into SO4, correct? Minus, and also ions will be produced. So these ions, the electrons will go through the positive, negative terminal of the battery, and the carbon rod, which a positive terminal will be deposited with the positive ions, and again if you connect, it goes. Now this battery will work as long as the entire zinc sulfide again broken, same as what lead acid. It will be split into zinc and zinc ion, positive ion, and electron will be stripped, SO for all this thing. After as you consume power I and it produce 1.5 volts, after 1 or 2 hours discharge, all the zinc sulfide inside the battery, which is a paste, will be converted into SO4 sulfide, will become black. Correct? Inactive material. Correct? So zinc also. So that means it can no longer produce electrons because zinc sulfide is not there. It become a pure sulfide alone. They have separated and they were stripped up. So then we say our battery is discharged. Dry cell is bad. Now this battery cannot be recharged. Correct? Recharging is called as from the external supply. Take another DC power supply. For example, 1.5 volts. If the battery is 1.5, you can give at least 1.6 or 1.7, little higher voltage or 2 volts, and from your electrical DC power supply, and you pump electrons. Correct? Pump electrons, then we supplying electrons, so that the SO4 and will be converted back and join with zinc. It will become again SO4, become an original electrolyte. In case of lead acid battery, the sulfide, which is black color material, they will be this one, and also it produces what you call PB. Correct? It become PbO2 also. Correct? Lead oxide. That is also inactive. So, but during this discharge process, you will see that the electrode size, whether the lead acid battery, this electrode size, correct, having some diameter, some length, make a solid material, this diameter will start reducing because the layer by layer, both the positive electron are getting reacted, correct? They release electrons, ions, and they become lead oxides, correct? PbO2, correct? And lead sulfides. Okay, so because of that, the electrolyte is gone, the rod size also reduced. Correct? So if you give external voltage, which is also recharging, the reverse process happens. Correct? Reverse process happens, and again the electrodes will grow. The amount of the H2SO4, correct? The amount of H2 will start increasing. Initially, it was broken into this one. So this process of reversing, creating H2SO4 molecules, also rebuilding the anode and cathode material is called as the charging process. For that, what you have to do? You have to provide external voltage which supplies electrons. Correct? External process, that we call charging process. That's how it works. So the primary cells, like zinc sulfide, the dry cell, which consists of carbon and zinc as electrodes, and zinc sulfide dry paste as this one, can be used only one time. They are called primary cell or non-rechargeable batteries. But if you take lead acid battery, lithium ion battery, nickel cadmium battery, they are called rechargeable battery, in which the reversing process is possible. As I told you, H2SO4 converted Pb and original lead electrode of the lead acid battery will become PbO2. correct? And so its size reduces, layer by layer, this was stripped off. That can be rebuilt if you supply the external power or potential along with the electrons. They are called charging process. That time, again, electrons will get into this one, and PB will become, PbO2 will become PB, and like that it built. We'll see the process, this one, how it happens. That process called as recharging process. That kind of battery is called as secondary batteries, correct? Primary battery is non-chargeable batteries, which is one time only you can use, which is called a dry cell example. Secondary batteries are the rechargeable batteries. Are example are lead acid battery, nickel cadmium battery, and also lithium ion battery. These can be called as rechargeable battery or secondary batteries. We know that. Okay. Now that we understood how it works, we will see the mathematical equation or the chemical equation which talks about charging discharging process. Okay. Discharging process, already we know how the current is created, breaking. Already I showed in the previous slide using, correct? This is the discharge process. Electrons are created, all this thing we saw. And during discharge, the chemical process I will explain. During discharge process, correct? You may be asked to draw the functional block diagram of your lead acid battery. As I told you, you have to draw this figure showing the positive electron, PbO, all those things, how ions, all those things. And also I explained how it works, the process you need to write. You can expect a simple 3-4 marks question. Okay. During that time, you are also expected to write these equations also. Okay. During the discharge process, what happens? The sulfuric acid. That's what I know. I told you, sulfuric acid is dissolved. This is the chemical name. I told you it will be broken, correct? That means the atoms are stripped or separated. That is called dissolved. That's what chemical engineers say or chemistry people say. And its molecules are disassociated. Breaking is called as disassociated. This is technically correct words. Breaking, we say physical, mechanical engineer, but these people into hydrogen ions. I call H plus. And in fact, I said 2H plus, correct? That is what the chemical, 2H plus. And sulfate. Sulfuric acid divided into sulfate ions, which are negative ions, SO4 minus. That means there are 2 electrons in one sulfate ion, which provides electrons, correct? Again, this hydrogen also produces, so this becomes positive. Okay. And these, once they are separated, sulfuric H2SO4 was broken into hydrogen ions and sulfite ions, and dissociate itself or dissolve and producing electrons also, correct? This done, then these ions are free to move. These ions are free to move in the electrolyte, because it is a liquid in which they can move in the electrolyte. This is the first step. How it happens, because step by step I am explaining. Okay. When the external load resisted, okay, what happens? It goes, the H plus ions will be deposited on anode and electrons are deposited on the cathode. So cathode becomes this one, negative terminal, anode become positive terminal. Okay. This is the first step. The next step, I connect my external, when the external electrical load. What is that? For example, resistor or a heater, right? Or a motor or a solenoid, any electrical device. we call it, which has some resistance, so it will need power. That should be supplied. When the external load is connected between the anode and cathode, positive and negative terminal, like this. I have this filled with this. This is my R. This is the positive terminal. This is negative terminal. Anode. Then current will flow I, and there will be a voltage V. Okay. So when it's connected, what happens? The connected between the terminals. Then what happens is the sulfate ions, which is nothing but SO4. SO4 minus moves towards anode. Okay, moves toward anode, and the hydrogen ions, which we call 2H plus. Okay, move towards cathode. Okay, so now that they move, what happens? My battery, once I connect, anode and cathode like this, you may load. This is positive, this is negative. Okay, so we can see that H plus are here and SO4 minus are here, and this releases 2 electrons. The minus means there are 2 electrons. These ions are the electrons are moving as a load I. Okay, this is what moving as I. Electrons are moving. Please note the direction of electron flow is opposite to the motion of current. Current flow, what we say always, positive to negative. This is positive to negative. This is the current direction I. This is the direction of electrons. Electrons are moving from negative to positive through load. You remember, correct? Negative to positive is the electron flow. Actually, anywhere if you say electron flow is from negative terminal of your power supply to positive terminal, DC power, correct? So, but the actual current flow, we call it conventional current flow, is anode to cathode. But the current itself due to electron flow only. Okay, this is that what I'm just saying. This is what happens. So we can see that finally there are 2 electrons are coming here. They will join with this and will become water. This is called as discharge process. Okay. So now we write the chemical equation. What is the chemical equation? At the anode terminal, note down all these things. And in the exam, you are expected at anode terminal, when load is connected during a discharge process, what the chemical reaction? What is anode? Pb. Lead is the anode terminal. What happens? SO4 minus moves like this and it liberates 2 electrons. Okay, and also it becomes SO4. Please note that this is called a negative ion. SO4 with the 2 electron, no positive charge, so it will be negative ion. So at the anode, what happens? This ion liberates 2 electrons and it becomes just SO4. Okay, this is called as sulfate. Correct? So this is called as sulfate ion because it has negative charge. Okay, and once it releases 2 electrons, then it becomes pure just sulfate, become neutral, and electrons will produce a current. This will move through the resistor, load resistor, to the positive terminal. Okay, through external. Okay, so that's what we say current. Then same time, because at the electrode, this is one process simultaneously. As this is happening, the Pb, because the anode is made of pure lead, Pb will react with SO4, which react this one. Right? So react with this, it produces PbSO4. This is called as lead sulfide. Lead sulfate, sir. Correct? This is what I told you. Yes, a black particles will be deposited bottom of this one because they cannot float. They have mass. Particles deposited in the battery bottom of battery. They are now inactive. What happened? One H2SO4 sulfuric molecule was separated. H plus, which goes to another terminal, and SO4, this K is coming to anode, and the anode, this reaction happens. Note down. This all this thing you have to write in the exam. Okay, this happened. Now, this same time at cathode, which is PbO2, lead dioxide. What happens? 2 H plus ions from where? From the H2SO4. I told you the broken to hydrogen atom, and electrons are stripped, so it becomes hydrogen ions, positive. So 2 H plus ion, this is a positive, is created. This will combine with, I told you there are 2 electrons released by this. So these 2 electrons, what happens? They are traveling from here to load and comes here. Correct? That's what I told you. Who created the lead, that is sulfide negative ion, SO minus minus, which was generated by breaking the H2SO4, and which came to cathode. There it released 2 electrons and it become SO4. Then it combined with Pb and it become PbSO4. Note down all these things. Okay. And simultaneously release 2 electrons. That is what your current that travel through a resistor and reaches the anode. This is my anode, positive terminal. What is made of? It is made of Pb. Correct? There already H plus electron ions are waiting due to the dissolving process of H2SO4. And these electrons will combine with this. What will happen? This with 2 electron, which is arrived from where? Arrived from cathode through the load, not internally, not like this. It is through external load, through the external load, and combines with positive. What it produces? 2H. That means 2 hydrogen atoms. Okay, 2 hydrogen atoms are produced at the cathode. Why? PbSO4, SO4 was created in the this other terminal. Okay, this doesn't stop. Next, what happens is this 2H2 reacts. Okay, to already what is the anode? This is made of PbO2 cathode. So we have PbO2 plus this 2 hydrogen atoms created. They combine, they create a chemical process, and finally they produce PbO plus H2O. Okay, so this is water, this is lead oxide. It's not lead dioxide, it's lead oxide. Okay, now this thing happens at the anode, this thing happens in cathode. What is the final product? You are getting PbSO4 and Pb and H2O4. These are chemical elements. What you are gaining? 2 electrons as a electricity. 2 electrons as a which is going through your external load, creates current. This current multiplied V generate electrical power. So now you know your lead acid battery, how it creates 2 electrons, flow of electron through the resistor is called a current. That current multiplied voltage produced, which is 2 volts by a cell, will produce the electrical power. If we integrate over the time, electrical energy. So this is during discharge process. Okay. Next, now that this process continue for 1 hour, 2 hours, once all the PbSO4 or H2SO4, all the H2SO4 are converted in this process. I said 10% remaining. So then fine, what you are seeing here, you said each and every time one H2SO4 is broken, then you are getting one water molecule, one PbO lead oxide, and one H2 PbSO4 molecules. Correct? This is what happens. So slowly, as energy is produced, as the electric energy consumed by battery, all H2SO4 will be consumed. Correct? From 10% it will become 0%. If you continuously connect the external load, this will happen. So the voltage will start discharge. It will remain constant for some time after the start discharging. This is my voltage. From 2 volts, it will after some time it will become, say after 1 hour, this will become 0 volts. Current will become 0. Correct? Current was there. Current also will start becoming 0. So at this space, the P equal to V into I equal to 0. Voltage is 0, current is 0 because there is no more H2SO4 to be dissolved and create electrical power. This is called discharge process. Next thing, what happens is the charging process. Okay, the charging process, recharging. Right? It is called a recharging. So I will complete this today. Recharging process. What happens is it is like this. That means you need to provide external power to recharge. This is my lead acid battery container. It is filled with electrolytes. Now there's no electrolyte. Please see that more are H2O4. Majority, correct? After if I say 99% or 98% will be water. Maybe 2% or 1% maybe remaining will be H2SO4. We can say that almost battery doesn't have H2SO4. That's why it is not producing. We say that it is completely discharge condition. Correct? It can become 10% water. That never happens. Okay, that's one thing. So water is there and with some amount of H2SO4, very small quantity. Correct? This is in discharge condition. Now I connect this to positive terminal. Positive terminal is made of PbO2. Okay. Then my negative terminal is made of Pb. This is my Pb. This is my negative terminal. Okay. So my negative terminal will be connected like this. Okay. Positive terminal connected to this. Okay. So we know that once we connect like this, the current from the positive terminal will flow and through this and like this it will continue. Negative. Correct? This process called as charging process, recharging or just a charging. That means you need an external power supply which can supply current I to recharge the battery. If you connect like this, what happens? Here in the anode, correct? You have 2H plus and SO4 minus. Okay? Like this. Now, the reaction, what happens is PbSO4. What happened? During the discharge process, at the anode, it creates a PbSO4, lead sulfate. It is no use. It cannot produce electricity. It is inactive material. Similarly, we got PbO and water. Water increases, the concentration of sulfuric acid reduces as more sulfuric acid is converted to water. Sorry. Okay. So now when you do this, PbSO4 plus 2H2O, water plus 2H converts into PbSO4 plus 2H2SO4. Please see that this is called regeneration. Correct? PbSO4 was created during the discharge process. Lead combined with SO4 minus release 2 electrons, correct, and become lead sulfate. This is what was created. Now that is when I give the external power, this plus 2 hydrogen atoms available as this one will generate PbSO4 and 2H2SO4. Correct? This is nothing but your sulfuric acid. That means you are regenerating sulfuric acid. Originally, H2SO4 broken and converted into PbSO4 water and PbO. Now you are regenerating from the PbSO4 inert material into again 2H2 sulfuric acid regeneration, molecule by molecule. Okay, this happens. Then we say that PbSO4 plus 2H creates H2SO4 plus Pb. This is happening, correct? This is happening at anode. This process, this is happening at the cathode during the recharging process. You can see that net result, what happened? I am again getting H2SO4 molecules at the anode, also in the cathode, and again I am recovering Pb. What happened? Previously, one was Pb was one this one. It was becoming PbO, correct? So now again this size of the electrode, this thickness of the electrode will start increasing. It will become bigger and bigger as you do the recharging. I am recovering back my Pb and also H2SO4 at both the electrodes. So my battery try to become original. So what will happen after the charging process? My water level will come back to 90% and this one will become 10%. That was supposed to. This is H2SO4. This is H2O. Okay, water. This was originally before discharging. If I recharge for 1 hour, same amount of time, approximately, but generally recharging process take longer compared to charging. That is another problem. Okay, for understanding, this will become, and also my Pb will be recovered. My electrode will become thinner and thinner. The Pb become PbO. Correct? We saw that the lead oxide. So that was again broken. O2 was separated. Pb was separated. Separated will go and deposit itself on the cathode. Correct? Pb will be cathode. So this process is called as recharging process. Okay, so we can see that this whole process, the recharging process, I know that time is up. I will stop in another 5 minutes. Recharging process, what final reaction? I can say that there are two things happen. One at cathode, other one at the anode. They both things finally regenerate H2SO4 and Pb and reduces quantity of water. Correct? Water is broken into 2H and O, and all this thing happens. Finally, these are many equations. There are many steps. I show the important steps. Note down the important step. What happens at the cathode? What happens at the cathode? The chemical equation during the recharging process or charging process of the lead acid battery. The whole recharging process, I wrote two equations, can be combined and can be written as PbSO4 plus 2H2O. What is this? This is water. This is lead sulfide. Lead sulfate. Both are after this, all this thing created during a discharge process. That means created from H2SO4. This was created plus it created PbSO4 plus electrical energy. Electrical energy we are supplying from externally. Okay, when you do that, this process is created. Okay, at both anode and cathode, and that's what everywhere you are getting this, right? This is sulfur. This will be converted back into Pb and H2SO4. That's what is happening, right? And for this to happen, we need to supply electrical energy, external energy need to be supplied. Okay. Now that we have talked about most important battery in electric vehicles or hybrid vehicles and automobiles, let me complete this by mentioning about what is the advantages of lead acid battery. Okay, one is it is a low cost compared to lithium ion battery or nickel cadmium battery. I am talking about rechargeable battery. You cannot use primary battery. One time use, then throw it. It will be very, very expensive. Correct? You cannot use dry cells similar to primary batteries or non-rechargeable battery for automobile, many of the industrial application. Because each time when you buy, you know that if you buy a torchlight battery, nowadays it costs around, I bought a small torchlight, AAA battery, correct? I put 3 batteries or 2 battery. Oh, if I use for 1 month, each time, each day, even 10 minutes, 15 when the power goes up, within 1 month, it's gone. If you go on as battery, you set up battery, they cost 40 rupees or 35 rupees. Previously, it was costing 5 rupees something, correct? Within the last 10 increase. So I cannot throw the battery, primary battery, and again buy new ones. So that's why rechargeable batteries are important. All automobile or industrial, they don't use primary battery like dry cells. They use only rechargeable lead acid, lithium ion, now latest, in between nickel cadmium. So it is a low cost. Lead is easily available. The material used in the battery is lead acid. Lead is one of the most abundantly available material on the Earth's surface. Correct? Compared to lithium, or we are going to talk about lithium ion battery where we'll use cobalt, all those things. They are all rare materials, very expensive. That's why lithium ion batteries are expensive compared to lead acid battery. Lead acid battery are very low cost, highly reliable. Already they were made long before. What are the manufacturing problem? All of the problem has been solved, and they are robust. Correct? Robust means they can tolerate temperature. They can tolerate high temperature, the environment temperature, and also abuse. Throw the battery, just all those things, still it can take some amount of vibration, all those things. That is called robust. Correct? Especially if you have put in your lead acid battery on your vehicle, it goes on a village road, uneven terrain. Battery will be jumping up and down along with vehicle. Still, they can withstand. Lead can withstand a lot of vibration, highly this one. And also, they can produce voltage when temperature. Most of the battery, if the temperature of the electrolyte reduces beyond certain, it won't produce chemical reaction. The Rodax process will not happen. Electricity won't. That's why if you go to cold countries, starting the electric will be very difficult. Battery will not produce current, voltage. Even lead acid battery, that is another issue. Antarctica, North America, where minus degree, all those things. So sometimes you have to heat your battery a little bit. Worst condition, correct? So they can tolerate some of the heat. The next one is they can tolerate, I can say that they are tolerant to overcharging. We are going to see that lithium-ion battery, if you overcharge beyond the full capacity, it can create heat and it can burn, burst, and create fire accidents. Compared to lithium-ion battery, the lead-acid battery are little tolerant to overcharging. Third one is they have low internal impedance. Internal impedance or resistance. Internal resistance, we call R battery. Please note that theoretically R battery should be 0 ohms. Correct? Theoretical battery. That means my battery has a lead electrode and has a lead oxide electrode and electrolyte. Lead has a resistance. It is a metal. It is not a superconductor. Correct? It is not a superconductor. So it has resistivity. And similarly, PbO, it is also has a resistance. It is oxide. It has more resistance than Pb. 2 electrodes have a resistance and you are connecting external resistance. That means some amount of energy will be consumed by the electrodes itself, I square loss. And electrolyte also has a resistance. So that means that's why if you start connecting external load, current, when you start consuming power, battery will get heated up because of the I square loss. I square are loss of electrodes and electrolyte because current is passing and they have resistance. So some amount of power is dissipated heat. Battery will get, if you discharge too much current, very high current, battery temperature can increase, it will explode. That's why if you short circuit your battery, lead acid battery, which are high current capacity, high amount of heat will be generated due to I square loss of the electrode itself, because they are made of lead and lead oxide. They have resistance. They are not superconductor, which zero resistance electrode. So low internal impedance is better because lead and lead oxide has much lower resistance compared to other anode and cathode like a zinc or something, correct? For example, carbon and zinc use dry cells, or lithium ion battery, or nickel and cadmium is this one. Compared to that, this is a low resistance. That means amount of power wasted in the battery is very less, and heating created due to power is also less. So this is advantage. Okay. Then it has a huge shelf life. Right? If a battery is there, shelf life, right? It has a huge shelf life. What it means, for example, you take a battery. When you buy a new battery, you know that the battery will not be filled with electrolyte. Let us go to this one. I'm talking previous. Now we have sealed batteries. Previously, you have normal batteries in which you buy the battery in a battery shop. He will fill the electrolyte in front of you and charge. Correct? Because I have done it some 10-15 years before. The sealed batteries, lead acid battery was there. Conventional battery, each compartment will be battery will be produced, but the battery company will not fill the electrolyte. If you fill the electrolyte, I already told you, the chemical reactions start happening. Some amount of leakage current, battery life will be reduced. So they do that. But once you have filled first time and start charging first time, after that, even if you don't use it, some amount of current, internal current will go, and because the battery will start discharging. For example, a lead acid battery 12 volt, correct? Car battery is there. Today 12 or 13 volts, fully charged condition. I did not connect any load. Disconnected from my car, put it in my cupboard. And after 1 month, if come and measure, the voltage will not be 12 volts. Instead of that, maybe 11 volts or 9 volts. That means internal discharge happens. That is called as leakage. Leakage current of inside the lead acid battery is much less because of that huge shelf life. That means it won't be quickly become unusable. Long life is that is one of the advantage. That means store the battery, but if you want to store it for a long time, not you going to use the battery, what you have to do is, suppose 1 month, 6 months, 1 year, you don't know, best thing is remove the electrolyte. Remove the electrolyte, just keep the cell in the this one, so that it can be refilled and again it be used. So huge shelf life is possible. The third, this one is it can become trickle charging. They call it trickle charging. You charge fully of 12 volts, correct? When a discharge, it becomes 8 volts or 9 volts, 10 volts. Again, you connect external power source charge to full 12 volts. After that, what you call the trickle charge, float charge. You give just a little, instead to 12.5 volts or something, correct? So small amount of current will be there. Internally, there's a leakage, that can be compensated. They call it trickle charging of the battery, which is allowed in the lead acid battery, which will prolong the life of the battery, lead acid. These are the primary advantages of lead acid battery compared to other batteries. Now, we saw that means in the world, everything is good. It also has some bad things or disadvantage. What are disadvantage of lead acid battery? One is very heavy and bulky. You know that you cannot, car battery or especially bus battery, it will be 20-25 kg. Carrying is very difficult. And sometimes small person like me, right? Now I will not be able to. So they are bulky for the given amount of energy which can store, correct? Then only 70% charging efficiency. Typical. Only 70% of charging efficiency. That means discharge, if you charge it, you will not be able to reach the full voltage. As number of days, number of charging cycle goes, it becomes lesser and lesser. At one stage, after 500 times, 300 times charge discharge cycle, it no longer can again recharge. So they say average is only 70%. That is one thing. Not suitable for fast charging. That is one of the drawback you all of you know, correct? Fast charge, because if I have a car with petrol ICE engine, my car has 30-liter petrol. I drive around 400 km, 350 km. My tank being empty. Go to fuel station, in 3 minutes, 5 minutes, they fill 3. Again, I travel 300. But if I use electric vehicle which uses lead acid battery, it to charging takes 5 to 6 of full charging. So that is one of the major compared to lithium-ion battery. Lithium-ion battery full charging takes 3 hours, for example. Correct? Now we have fast charging, quick charging, 1 hour, 50 minutes, 30 minutes, all those things. But I already take this one. This with 2 to 3 times more compared to lithium-ion. That is one of the major. Fast charging is not possible. Sometimes danger of overheating. Overheating happens due to high charging rate. Correct? They call quick charging. High charging rate or quick charge. If I want to reduce the charging time, what you have to do? You have to pump more current inside the battery by external power supply. Correct? That means instead of 10 amps, you supply charging current to the battery makes 10 amps. The easiest it will take 5 hours to full charge. You want quickly. What you do? One way to do is you increase 15 amps current. Correct? It may quick, but it will create overheating. Correct? Because internal resistance of the battery, then it can catch fire. All this. That is overheating due to fast charging. If you try to do fast charging, then last one is it has life cycle. Life cycle, which is called as charge discharge cycles. Charge once, use it. Again, charge once, charge plus one discharge cycle. Like how many times? Cycle is generally 300 to 500 times. Conventional, this one. There are deep charging batteries, which is very expensive. Lead acid is available, special design, which can go to 700 times, 600 cycles. Correct? But they are very expensive. But conventional, this one, these are the major drawback. Okay. So with this, I stop here. Due to these disadvantages, advantage is good. Due to disadvantages, people are looking for new type of battery. There's a nickel cadmium battery. They invented some 50, 60 years before, which is much better than lead acid. After that, this also has some limitations. So they invented lithium ion, which is very popular. Okay. We are not going to, nickel cadmium batteries are not used in automobiles. We are not going to talk. I'll be talking about lithium ion battery, what is internal construction, like what we saw, what happened, the anode, cathode, all these things, and what is advantage, disadvantage. With that, battery will be over. After that, I will talk about supercapacitors, which is a replacement for battery. Even lithium ion battery has limitations, advantage, disadvantage. To overcome that, they have invented what you call the capacitors are there for last 100, 200 years. They improved a new type of supercapacitors compared to conventional. I will talk about that 2 lectures in this one. As I told you, from more remaining lectures, now batteries, this one, and also talking about other 5 lectures, 5 to 6 lectures, which talks about the configuration, power calculation, torque calculation, designing this one, all these things also will be recorded and will be put on Google Drive and will be shared with you. And if you want anytime, you can go through all of you, because I will do some 4 to 5 lectures before Friday, and it will be available on Saturday, correct? Including lithium-ion battery, supercapacitors, and also something. All these things will be put on my Google Drive. By Saturday, I'll be shared. Okay, for 4 to 5 lectures. And before next Wednesday, I will record remaining 5 to 6 lectures on other topic, which is very important, and that also will be recorded and sent to you. 99%, this will be my last class, unless you want this another online classes. Other things will be as a recorded, because I have some very important work for next 2 weeks, which I am forced to travel between different Bangalore and some other cities also. I won't get internet link, proper link, this kind of quality connection. That's why I'm going to record and tell you. Okay. Again, the portion will be whatever video lecture which I am sending, and also what I taught from the day one. Already we covered around 30 hours. Those lectures plus the video lectures will be portion for your NSEM exam. Date is already fixed. You'll be physically coming to IIT Madras and meet in my room. You know, timing, all those things already we informed. So it is a 3-hour exam and you'll be writing at MSB 358. Note down. It is called Mechanical Sciences Block, room number 358. In the same floor where I am sitting. You know my room. Last semester you came, all those things. You know, it is called Mechanical Sciences Block. And this is a physical exam. It is not online. If somebody doesn't write, we will not conduct exam separately for you. That's why we prepare 1 month before. I'm going to US, I'm going to my companies and all those things. We can't help it. Again, each and every person will give. Please note the dates are told. That's why 1 month before, you book your tickets. Already we told. Tell your company, this exam will happen. You cannot go. Even foreign assignment. Sometimes students say foreign without that I cannot do. We can't help it. Okay. That is very important. Note down. Those days you
Noted,
come
sir.
on.
Noted, sir. Everything noted.
Yeah.
Sir, my humble request,
Yeah.
sir, whatever the lesson, whatever the video you're going to record, sir, maybe some important things you can tell, sir. Then from that we can get some idea.
No. You know that, no? Note down this equation, note down these formulas, note down this. I'm telling this today also, no? Every class I will tell that. Correct? But you know that, no? So that's how it works. Okay. Thank you. No, but
Thank you,
again, one more thing. If you want 1 or 2 hours, again, online, for some clarification, I could do that. It's not that impossible. Correct? Next week, this week, 2 days, I am not available. Tomorrow and day after. And also Friday also, I don't know. Again, next week also, Monday, Tuesday, 99%, or Tuesday, Wednesday, I will not be available. Correct? And so I thought that this is similar to what I go to record and tell what you are going to see the this one PPT on which I whatever write with my voice. This is a video recording, correct? So you can see it. If you have any this one also, you can call me. Okay.
Okay. Thanks, sir.
Okay, thank you, sir.
Thank
Okay,
you.
sir.
Have take care. Have a nice weekend. But anyhow, I will send you the lectures this weekend. That is Saturday. You will get 5 video records. By next Wednesday, Thursday, another 4 or 5 records. With that, portion will be over. Okay.
Okay, sir.
Thank
We'll
you.
meet on 11th. We'll meet on 11th, sir.
11th at MSB 316 or 358. You